Hello friends, today we are going to calculate the support reaction of given portal frame using the minimum energy principle or Castigliano's second theorem. Now observing the figure, we have the end support as a hinge support. So reaction at location A as a RA, reaction at location D as a RD, and assuming horizontal reaction at location A as a capital H, and observing the given frame there isn't any horizontal load, hence due to the sigma H equal to 0 as a equilibrium condition, we have to assume horizontal reaction at location D of as opposite of horizontal reaction at location A. So our reaction at location D is capital H, same as the reaction at A, but it is in the opposite direction. Now in this frame we know that total number of reaction is 4, which is RA, HA, RD and HD, but HA is equal to HD is equal to H. So let us take this capital H as a redundant in this example. So using this H, first we have to find out RA and RD. So taking sigma moment at location A equal to 0, we will have RD into total span distance as a 6 meters. So it is 6 times RD in anti-clockwise direction. Now due to H, total moment at location A is 0 and rest value is 50 into 4 in clockwise direction. So it is equal to 50 into 4. Now solving this term, we have RD which is equal to 33.33 kilonewton, and if we take sigma V equal to 0, we will have RA plus RD which is equal to downward load as a 50 kilonewton, hence the reaction at location A which is equal to 16.67 kilonewton. So using this equilibrium equation, we have RA as a and RD as a now according to the Castigliano's theorem, we have to take a segmental part as a to B and taking A as a origin. Similarly C to D and D as a origin, our cross section is look like. So from segment A to B having 4 meter span, we have moment at location XX which is equal to, now at location X, if we assume this part as a left hand side part and anti-clockwise moment as a negative, then 16.67 into perpendicular distance is 0, hence the moment due to 16.67 is 0, and H into span distance which is as a X and in anti-clockwise direction it is negative, hence the moment is H into X, but it is minus H into X. Similarly, if we take the CD segment having a 4 meter span and origin as a D, then segmental distance is X. Now at this location our moment is of a clockwise direction and sectional right hand side clockwise which is treated as negative, hence for C to D segment also our moment is as into X, but it is negative. Now going ahead for the next segment, as from given span we have B to E of 2EI, and for B to E if we take the origin as a B, and for E to C segment if we take the origin as a C, then segmental part is look like, where for B to E segment total length is 4 meter, and if we take B as a origin then sectional distance is X, and if we take the moment at location XX 16.67 into X in clockwise direction, so moment in BE segment which is 16.67 into X and H into total height, and total height is given as a 4 meter, so H into 4 in anti-clockwise direction and sectional left hand side anti-clockwise moment is negative, so it is minus 4 into H for B to E segment. Now going ahead for E to C segment, our sectional distance from location C is X, total height is given as 4 meter, and if we take a sectional moment at location XX then 33.33 into x in anticlockwise direction, and as per the sign convention, sectional right hand side anticlockwise is treated as a positive. Hence, moment at location xx or E to C segment, which is equal to 33.33 into x and h into 4 in clockwise direction, and sectional right hand side clockwise is negative. So, it is minus 4 into h. So, first of all we have to calculate the support reaction. After that we have to take the segmental part and find out the moment. Now this moment is going to be used in Castigliano's tabular form, as now according to the segmental part our moment is as given in the tabular form, and observing the given frame we have A to B as a I, C to D as a I, and B to E and E to C as a 2I, which is reflected in the part of moment of inertia in BE and EC segment as a 2EI, and the limit of the segment is the segmental distance of given frame as a 4 meter for AB, 4 meter for C to D, 4 meter from B to E, and 2 meter for E to C. So this is the moment of section as we calculated, and for partial derivation we have a Castigliano's mathematical equation for minimum strain energy or second theorem as total strain energy at the location where deflection is 0. Hence at location A or at location D we have strain energy as a 0, and mathematical equation says that it is a 1 by EI integration over entire span sectional moment into partial derivation of the sectional moment with respect to redundant. So in this case we have assumed redundant as a capital H dx for each segment. So total strain energy, which is 0, which is equal to summation of these all segmental part strain energy as a UAB, UCD, UPE and UEC. So we have to calculate first all the segmental strain energy and summing up all the energy and equalize it as a 0 to find out the value of H. Now going ahead for the partial derivation of given moment with respect to redundant as del mx by del h. For first term it is minus hx, so partial derivation of this moment with respect to h as a minus x. Similarly for second term both are equal, hence the partial derivation is also equal as a minus x. For B2E segment 16.67x with respect to h as a 0 and minus 4h with respect to h as a minus 4, and for E2C segment 33.33x with respect to h as a 0 and minus 4h with respect to h as a minus 4. Now using this tabular form and equation of strain energy, first we are going to calculate strain energy in AB and CD segment as, now first for AB and CD segment we have UAB plus UCD as a 1 by EI is constant for both the term. Now integration limit is 0 to 4 for A to B segment. Now moment of section as a minus hx and partial derivation as a x. So multiplication of moment with respect to partial derivation as a mx into del mx by del h, which is minus hx into x as a h x square dx for A to B span, and for C to D span both the term is equal, hence it is multiplied by 2. Now solving this term we have 1 by EI is constant, 0 to 4 2 h x square dx, and integration of x square dx as a x cube by 3, and limit is given as 0 to 4. Now closing this limit we will have summation of strain energy in AB and CD segment as a 1 by EI is constant and rest term which is equal to 42.67. Now going ahead for the strain energy for B2E segment, which is strain energy in B2E segment. Now for B2E segment our I value is 2 times, hence it is 1 by 2 EI. Now limit is given as 4 meters, so integration of 0 to 4. Now multiplication of this moment with partial derivation. So 16.67 into minus 4 into x as a minus 66.68x and minus 4h into minus 4 as a 16h dx. Now integrating this term with respect to dx, we have 1 by 2 ei as a constant minus 66.68. Now x dx integration as a x square by 2 plus 16 into h and constant dx as a x and limit is 0 to 4. Now closing this limit, we will have and solving this term, we will have strain energy in B2E segment as a (32h minus 266.72 by EI). Now same equation is going to be used for the EC segment, and the strain energy in EC segment, which is now for EC segment, moment of inertia is 2 times and segmental limit is 2 meter. So 1 by 2 EI 0 to limit as a 2. Now 33.33 into minus 4 into x as a 133.32 x and minus 4h into minus 4 as a 16h dx. Now integrating this term with respect to dx, we have x dx integration as a x square by 2 and constant dx as a x and limit is 0 to 2. Now closing this limit, we will have upper limit is 2, so 2 square by 2 plus 16h into 2 and total value of the strain energy in EC segment, which is equal to 16h minus 133.32 by EI. Now summing up all the strain energy, we will have from above calculation, we have calculated the strain energy in each segment as shown, and summing up all these value, we will have now equating this term, total H is 42.67 plus 32 plus 16 as a 90.67 H minus the constant value is 400.04 must be equal to 0, and solving this mathematical term, we have capital H as a 4.41 in terms of kilonewton. It means our redundant reaction at location A and D in horizontal direction, which is 4.41 kilonewton as we have calculated. So thus we can calculate all the support reactions using Castigliano's second theorem, which is a minimum strain energy concept. Thank you.